Hey chat, John here. I'm the lead maintainer of Latterly.io. Latterly is a software engineering career development platform that'll help you learn to code and land your first or next programming role. Lots of interview prep, networking. You can join the Discord for free. And today we are working on Aria's tail rag. This will be a multi-part stream, so it's going to take more than one stream. I'll be working on this. The current stream is quite modest. I'm going to explain what a rag is, what the Aria's tail rag repository scope includes. Then I will get my working code into a demoable iteration, and then I'll save that and I'll push that, and that will get the code off of my current computer so that I can pick up another stream on a different computer where I can stream to more platforms. The current computer is limited in the streams that I can stream to. So we're currently streaming to X, Facebook, Twitch, YouTube, and LinkedIn. But I'd also like to stream to TikTok, where the bulk of my audience is. Okay, so what is Aria's Tale and what is a rag? So Aria's Tale is an emergent narrative world drawing on elements of fantasy, science fiction, and isekai. So it's a long-running thing that's been involved in the Latterly community. You can go to Latterly blog article 5 and read more about it. But basically, when generative AI started to come on the scene, there were lots of generative AI tools for making images and videos and language like text. And I thought, hey, let's try to build some games and let's try to build a fictional narrative universe with elements of sci-fi where we can chat about this problem of dealing with AI. So that's what the Aria's Tale website is. It has a few games. And this is a rag, which will function as a game encyclopedia. So you'll be able to chat with this rag. So a rag enables certain tools, including in this case, will enable a chat tool. And you'll get to learn trivia. It's going to work like a game encyclopedia. Okay, so the repository scope includes a classic rag and an agentic rag, and we'll cover the differences there. Basically, the difference is that the agentic rag will use Google ADK agents, and the classic rag will not use the Google ADK framework. So we'll do it two ways. Why do it two ways? One is I want to show you the classic approach so that I can teach people how to do a rag, but I want the agentic approach for myself because I greatly prefer it. So it's a little more advanced when you're learning generative AI and AI engineering. Agents are kind of a second step, but they are my preferred step. But I don't want to just like skip over the basics. So that's the reason that there's going to be two in this repository. And what is a rag? Rag is retrieval augmented generation. So this is a technique in generative AI that assists with a number of use cases, two that are top of mind. One is it can mitigate hallucination. So language models frequently hallucinate. One of the reasons for this is that they are biased to their training set. So if you have a case, like in the case of Aria's Tale, a lot of the foundation models that we might use, like OpenAI, they're not really trained specifically on Aria's Tale. So we can include an index of Aria's Tale specific data, and that is like a database. And then we tell our agent to retrieve facts from this database and keep those in mind in context when it's formulating responses. So that's retrieval augmented generation, in this case, text generation. So that's what a rag is. The first is to mitigate hallucination and then provide, and then the second is when you have so much context that you can't just provide it to the language model in the context window. So you might technically overflow the context window, or you might underflow the context window, but we know that as you saturate the context window, performance degrades in the language model. So the Gemini foundation models, which we'll be using, are world leaders in the size of the context window, going up to 2 million tokens. Now, we don't have 2 million tokens in this encyclopedia, but even if you get to the halfway point, or even like a few 100,000 tokens, you'll notice performance starts to degrade and the model starts to become overwhelmed and confused with so much context in mind. So a rag lets us selectively pull the relevant bits of a large context, selectively pull the relevant bits, and then apply those to the current chat. So Aria's Tale is a broad and diverse world, but maybe we just want to talk about character classes, or maybe we just want to talk about items or artifacts or places. And we don't want to have everything in the mind of the agent. We want it to focus on the particular question. So it'll give you more precise, accurate results. In the vocabulary of data science, we can expect a higher F1 score, accuracy, precision, recall, and so on. So better performance. And then there's also engineering performance too. In terms of cost efficiency, when there's less context sent every message, it's going to be cheaper. And there are latency benefits too, which is also an engineering performance. So performance in both ways, in terms of engineering traits and also in terms of data science qualities. We get both kinds of benefits when we use RAG. And you don't always get them, by the way. So it's worth noting that like we shouldn't always implement a RAG. Sometimes you do get better accuracy, precision recall just by stuffing all the information in the context window. So what you would want to do in practice, if you're trying to optimize on accuracy, say, is you would try both approaches and then you would do an evaluation and you would look at which is giving the more accurate result. But in many cases, particularly with a large set of context, RAG will be beneficial. Okay. All right. I think that gives you the background of Aria's tail and RAG, so I'll close these out. A little history on the repo. This is based on the Gemini Full Stack ADK Quick Start. So if you want an agent, but you don't want a RAG, this will be a better repository for you to start with. If you want a RAG, the hope is it's not currently there yet. It's a work in progress, but this will be a better place for you to go for a sample RAG application. But if you just want an agent, there's already this repository. So I basically copied the architecture here, and then we'll be changing things inside of the backend and front end. So Aria's Tail Encyclopedia is in our Vite UI. That is not mentioned in the Full Stack ADK, but that's a bit of the history. How did I create the source data set? I went to ChatGPT deep research mode, and I asked it to create a CSV with these columns: asset kind, value, and notes. And an example of an asset kind could be a character, a class, place, item, ability, narrative beat. Hopefully it went beyond that. The idea was just to give it some examples. So it also came up with organization. Great. So in the narrative universe, there are guilds, and ChatGPT called that an organization. I'm very happy about this. So it created this large CSV of elements that exist in the game world. And then I'm copying that over to be the data source, which we will select from. So certain rows will be selected and then added to the chat context to proceed with content generation. That's one thing to note. Okay, that's how we got the source data. Another thing that's interesting based on the history is I didn't rip the ADK Quick Start directly. I actually ripped it from this pull request that I did, which is in turn related on this. But you'll see something about horse facts. And that was a toy application that a student of mine, Shu, was working with. And so that's kind of like the latest. And that's actually where I literally pulled it from. So if you see something about horse facts and you're like, what's going on? That's where it came from. But they ultimately descend from this upstream repository. And then one more plug for Latterly. I showed you the basic site with the UI when you're not logged in. When you do log in, there's like a cool journal tool, which can help with your career acceleration. All right. So now we can actually focus on the code at hand. Here we go. So here you see I have staged the deletion of 2 agents. So in the toy repository with Shu, it's a multi-agent system. So when we think about AI agents, a single agent is an agent. When you have multiple agents working together, that's a multi-agent system. And so technically, he has an orchestrator, and it would delegate either to a search tool or a custom tools agent. And the interesting thing about the Google ADK is that a search tool is a built-in tool. So we can give agents tools, as you see here, tools, Google search. But in the current implementation of the ADK, maybe they will fix this in the future. This is July 2025. Currently, you cannot mix built-in tools with custom tools. There are some workarounds, but this is one of them. So it would enable his agent to search Google when needed, and then to use custom tools when needed. But I won't need that in the case of Aria's Tail, because I'm going to basically disable web search, and I will have it use these tools. So why am I using an agent at all? Why don't I go for the classic RAG approach? And that is because I'd like to use tools. So with the classic RAG approach, I would just retrieve the text out of the CSV and then proceed to text generation. In the current case, you can see I have 2 tools, not just one. So there is a RAG tool, which is currently just an alias on horsefact. We'll build out the implementation later. But there's this other tool to roll a dice. And this is really nice because Aria's Tale is like loosely inspired by Dungeons and Dragons and RPG games. And when you do such a game, you often want to roll a dice or roll a die. So it's convenient to have an agent with access to multiple tools, including at least these tools and potentially other tools. That's why I prefer Agentic RAG over pure or classic RAG, is because in many cases, we want to add other tools into the agent besides the RAG literal, so that when appropriate, this agent can pull RAG, and when appropriate, this agent can do something else like roll a die. Roll a die is an interesting case for a tool, because if you just go to ChatGPT or a language model and you ask it to roll a die, it will give you a result. It will simulate a result through the language modality, but it is an unfair distribution. So when we roll a die, and you can see it, I'll show you the code. It's just taking the Python random library, but this is essentially fair. It's going to give you an even distribution between 1, 2, 3, 4, 5, and 6. Or if I go to a language model, it'll give me numbers, but you'll see that the distribution of response is biased distribution, again, owing to that training set data. So any case where we want deterministic logic, and this is like a trivial case of deterministic logic, it's nice to use a tool, particularly when dealing with math. Language models are trained to recognize tokens. It's technically an autoregression model for tokens. You can think about tokens as similar to words or characters. That's not technically right. Technically, it's inefficient for a model to spell out every character, so they predict on a token, which is a character grouping. If you're familiar with a trie or a tree, those are much closer. Those prefixes, a prefix tree, those prefixes within the data structure of the trie are essentially what we're talking about by tokens. So you can have a single character in this prediction, or you could have like a group of characters. A common would be a root, like a Latin root. So if we think about the word prefix, PRE is a common root, which is often used together. So in a language model, which is trying to predict, it's a good target of prediction to target PRE instead of just predicting P and then going for R and then going for E. It's more efficient to just outright predict the PRE. Okay, so that's a bit about what token prediction is doing. And when we deal with numbers, they are trying to predict tokens, so they're not actually processing math problems. So you can search the web. There are plenty of these examples where a language model is unable to give you the correct answer to a math problem because that's not how they work. But tools can work that way. Tools can do deterministic and complex math. Even though this is trivial, I could put something complex here, and it would work basically every time. So that's a huge benefit. It's really hard to drive home how beneficial deterministic tool usage by agents is. And that's, once again, why I prefer Agentic RAG over classic RAG for most use cases, because in practice, when we're building complex tools, you're going to want to have a subcomponent or a subroutine, which is deterministic. And that helps, again, mitigate bias, control risk. Whenever we deploy these AI agents, we're always worrying about like risk that it might hallucinate. So these sorts of tools mitigate against that. Make sense? All right, hope you're hanging with me. I don't see anything in the chat yet, but feel free to chime in. Okay, so with all that background, the base ADK and then shoes application are all working, but now that I've deleted these, I'm not sure that it's naively working, but I'll give it a shot and we'll see what errors are visible. We'll fix them, save, and then that will be the scope of today's stream. I'm hoping that we get to a place where here I can like type something in and get a response, even though it won't be the final response. We also need to do, in a later stream, I'll do some things around data cleaning. So in this result from ChatGPT Deep Research, there are some unclean values. So you can see OpenAI included these citation markers for OAI cite. It's good that OpenAI is citing their sources, but I don't want these to show up in the final results. You can also see things like grammatical quotes, where I prefer literal apostrophes over grammatical quotes. And same with these M dashes, where I prefer like a regular dash. And then I guess there's some hidden character here. So some data cleaning things, but I won't worry about those now, but we'll deal with those in the next stream. So whenever we construct a RAG, it is an important step to clean your data that you're indexing for the RAG. And then we will loop in Supabase for the vector search and indexing. Basically, that's going to be our database, but I won't be doing that here. Here, I'll be working with this alias, so you'll see a bit about horse facts once again. So here, and now I have a root agent that I'm exporting, and it will be spitting out horse facts when you might expect facts from the RAG. So that's the reason that that's going to happen. Okay, so to get started, the structure of this repository is that there's a backend, a front end, and a Docker file. Okay, and so we're going to try to get the Docker file approach working. And you can look through the READMEs, like the README will tell you how to build the Docker container. And there's another README specific to the backend. So I've already done this, but basically UV for package management. This is faster than pip, which is the Python package manager. And then in the front end, we'll be using Node package manager npm. Okay, so I've already done some of these steps, but if you were trying to follow along, you would install UV and walk through these steps. And then you'd be able to access the playground. Let's just go to that playground now. The playground, oh, yeah, that might work. I think that'll work. So the playground is built into the Google ADK, and I will select the agent from source, and I will say, how many horses exist? Okay, no module named orchestrator. So here's our first issue. We'll fix the playground and make sure the playground is working before we proceed to the Docker file, and then the UI last. That will be the order of operations. So the orchestrator is not found because I deleted it. I guess I can leave the load.env here. And so I'll just delete this. And we'll see if that solves it. So I want it to be pulling from this agent file, but I might need to import, from agent, import root agent, but I'm attempting to export it here. So the playground is looking for that root agent declaration. I think it has hot reloading, so I think I can just refresh the page and I don't need to restart the server. I'll just say, hi. Hello, how can I help you today? Roll a die. Okay, so we can see that the roll a dice tool was triggered and you rolled a 3. Let's just prove that it's rolling again. I rolled a 3 again. Wow. What are the odds? Okay, we're getting different numbers, so it's not just saying 3 every time. There's really the Python random process running. And I'll say, tell me about horses. And we can see that create a horse fact got triggered. Here's a fun fact about horses in Aria's tale. Horses cannot sleep. This is what I expect. So this is a lie. Horses really can sleep, but this proves that the tool is working. And this is an interesting kind of test-driven development technique for agents that you can do. So we're using the create a horse fact tool and it pulled out of here. This is kind of like a micro RAG, by the way. It's retrieving information out of these facts instead of out of some database. But because it told me horses cannot sleep, I know that's not due to the foundation model because the foundation model thinks that horses can sleep. So by inserting a lie into the tool, when I detect the lie, I have high confidence that it came from the tool and that it wasn't just, from the background information that the training model endowed. Okay. So good. So the playground seems to be in working order. I'll stage the agent. I'll stage the init file. And I'll stage the source CSV. Why not? So now I will proceed to the Docker. And here I'll say feed, or I'll call this, yeah, this is actually 2 commits. Let me unstage these. Update source. So that's 1. And then here is RM orchestrator. So we're not working with a multi-agent system anymore. We're down to a single root agent that has a couple tools equipped. Okay, so to get Docker working, I will navigate out of the backend folder into the root folder, and I will build from the Docker file that's located in that root. Here's the Docker file if you're curious. We're using Alpine. And it grabs the front end stuff, which we haven't built, so the UI will not be natively active. But then it grabs the Python code from the back end and it runs it on Uvicorn. So we're running an Uvicorn server inside of Docker and exposing quad 0 port 8000. So whenever this completes, I'll expect this URL to be live. This is synonymous with localhost. So I should also be able to reach it at localhost 8000. Okay, so we built our container. I already have Docker running. No module named orchestrator. Okay, so let's keep looking for that orchestrator. Good, so it's being imported in the app. That's why this is failing now. Okay, so root agent is necessary for the runner. The runner is an abstraction that wraps the agent so that whenever an end user in a web UI sends text to a server, the server can then pass it to the agent through the runner and generate the result. Okay, so the solution is basically I need to import the root agent from that other file. I'll go ahead and do that now. But just so that you can get a little more context on what's going on, we can see here's the runner. And the runner is running asynchronously to generate a data stream, which is returned to the client when the invoke API is called. So when we get to the UI, I will be sending a post message to the invoke endpoint, and that will produce a response that's sent to the UI in a way that the UI can parse. Toel on Twitch, welcome in. Thanks for the insight, very welcome. Okay, so that's basically how we communicate with the front end. Let's see what else is going on. There's some unit tests that are broken. I don't care about that so much. This is the other repository. So let me make sure that I'm restricting my changes to Aria's tail rag. Okay, and then I'll ignore the JSON file. I don't care about that entry. So I still have top level txt. This is within the virtual environment, so I'll ignore .venv in my search. I'm just looking for things which would impact the runtime. So I'll just delete this unit testing file, actually. Unit testing is good. I'm hesitant to delete it because unit testing is good, but so many of these unit tests are irrelevant in the context of the current repository. So, but the README does mention unit testing. So what I'll do here is I'll open up Composer. So we're using Cursor, not VS Code. And I'll say remove references to orchestrator or smart orchestrator as these entities have been deleted. So I could look through these one by one, but I'm just going to ask the Gemini 2.5 Pro AI tool to kind of read the file and delete the irrelevant unit tests. So I'll CD back into the backend folder and just regression test this unit test suite pretty quickly. I guess it's a worthwhile exercise. So in the context of unit testing, we make an in-memory runner. And we can look in more detail at the changes made. So we deleted the setup dummy runs. We deleted this. We created a test for API integration custom. So it will still make a mocked API call to show that that invoke connection to the service layer is working well. I don't know if this is going to pass or not, but that seems fine. This time import is also unused, so I'll delete that. Okay, so I'll UV run PyTest, and this will run this test unit file. Okay, no module named source agent search. That's right. This was also deleted. So I'm expecting that it will delete this and probably this unit test. Okay, we don't need the Google search tool anymore. The root agent is not used. I'll comment that instead of deleting it. I don't want to make this stream about unit testing, but in principle, I should actually test the new root agent. We get a bunch of failures, but they're coming from the integration test suite. So here I'll say test unit.py. So we'll specifically run, source/test unit.py. We'll specifically run this one file. It's also trying to run the integration tests concurrently. Okay, custom agent is not defined. We have 3 failed, 2 passed. Yeah, there is no custom agent anymore. I don't know, maybe I can swap custom agent out for root agent. So this test is just checking that the tools are equipped. So yeah, that seems fine to use with the root agent. Okay. Any other reference to custom agent? Only in the function name, but let's go ahead and change that as well. So the root agent, test root agent has tools, good. And this test exercises the root agent with real API calls. I don't know that it really does that. So it's going to make a runner. I'm just going to delete the word real. So it's testing that that API connection to the invoke method is working. Okay, that seems good, but there are some partial stubbing there. So I'm suspicious about the word real. Real to me implies it's an integration test, which it's not. Okay, so this looks good. We're passing, so I'll stage that. And then what happened over here, we changed the name. Any other references to orchestrator, orchestrate, or only in the instructions. So I'll update those instructions as well. To do that, I think there's a script for creating, script for creating Copilot instructions. So UV run scripts, create Copilot instructions, and I'm using the tab key to complete the name of the file under running. Okay, so that's already done very, very fast. Thanks, UV, for being so fast. And we can see it got updated to remove the now deleted files. So we'll stage that as well. And then I search for orchestrator, and this is egg info, which is part of the build process, egg info, egg info. Okay, so I can just ignore, these are build artifacts. Good, so no more references. Okay, so the fix here is mainly unit tests. El Abimana, what AI agent you use? So we are using the Google Agent Development Kit, the Google ADK, and you can look in the pyproject.toml file. The library name is Google ADK, here it is, and we're using version 1.5.0. Since you recently joined, I'll just remind the audience that this is in the Aria's Tail RAG open source repository in Vanderveer. That's my last name. Good luck spelling it. So here it is, and you'll be able to go to backend pyproject.toml and see the library here. And we use both the Agent Development Kit and the GenAI library. We're using both of them. So this will empower us for the classic RAG, where we don't use an agent, an agentless approach. And stars are welcome. I only have 1 star, and it wasn't from me. So thanks to whoever did that. Okay. So now let's try Docker again. So we'll rebuild the container. I'm just pushing the up arrow on my keyboard, which will navigate through the command history in recency order. So most recent run commands are presented first when I tap up, and I will keep going up until I find the run command now. And it's running the container by name. So I'm tagging the container with a name. That's the -T. So it gives it a name basically, or a tag more precisely. And then I can run it this way. Okay, so it looks like Uvacorn is running now. So 8,000, nothing is here because I expose the app as a get method on /app, and I expose invoke as a post method, which I won't be able to access this way. Method not allowed. Good, that's expected. App, I don't see the app because I didn't build the front end, but I expect that the back end is working now. And so how will I use the front end? I could build it and deploy it through Docker, but I'm going to instead npm I, which I think is already done, and I'm going to run the front end. Let me deactivate my virtual environment since this is not to do with Python. I'm going to run the front end in development mode. And so it kicked off a Vite development app on a different port. So this is a different UI not going through Docker. Okay, and it worked. And let's see if I can get anything. Roll a die. Cool. All right. So similar experience to what we did in the playground over here, but now we're using our own custom UI, Aria's Tail Encyclopedia. And I'll say, tell me a random fact about Aria's Tail. And I expect that it will instead tell me a fact about a horse for reasons we described earlier, because I haven't integrated the proper RAG. I've just aliased a horse fact tool. So going over that one more time, because we had some recent joiners. When we look into the agent logic, the Aria's Tail RAG tool, let me call it Aria's Tail RAG tool. It's not the RAG, it's a RAG tool, which is a little bit different. So technically the tool will include a reference to a RAG, but the RAG entity itself is a different data entity. So I'll call it the RAG tool to be a little more precise. But currently it's just an alias to this create horse fact tool. So we're not expecting to pull from that CSV that I mentioned earlier yet. By the way, I'm going to plan to do Postgres indexing, but you could use a RAG directly off the CSV. It would still be a RAG. So a lot of the online information that you'll see about retrieval augmented generation, they assume that there's a vector store. They assume that there's indexing going on, because that's kind of the hard part, or one of the hard parts of a RAG. So that's why it gets so much attention. But technically, any data source that you retrieve from is a RAG. Like I said earlier, that even this horse facts is a micro RAG, even though it's done in memory. Similarly, if I take a flat file and I read it in, and if I retrieve a subsection of it, that is still retrieval augmented generation, even though I'm not using like a vector search or a Postgres with indexing. Okay, so that out of the way, tell me a random fact about Aria's Tail. Here's a random fact for you: horses cannot sleep. So it triggered that create horse fact tool. Okay, so this is a minor feature, better RAG tool naming. All right, and that concludes it for the current stream, y'all. Thanks so much for being here. I hope you'll follow for part 2, where we go over the Supabase integration. We're gonna clean the CSV, ingest it, index it,